wanted to talk a little bit about not being bored with technology. I want to talk a little bit about some of the things that workstations are actually doing and solving real problems for people. What workstations are capable of doing, they're the computer that you count on when you've got to do something interesting. I was looking at a Discovery Channel program a couple of weeks ago, and they were talking about the creation of Spaceship One, the X Prize winner that put a non-government person into outer space. And there, right behind the head of the person doing the analysis for the re-entry of the spacecraft was a Dell Precision workstation. Now, there's a case where that's critical computing. If you're the pilot of Spaceship One, you really want to know that that analysis was done correctly. So the whole thing is ideas are enabled by workstations. And we really want to talk not just about the speeds and the feeds, but what do people do with workstations and how can you get more out of them? The workstation is the platform you use when the results actually really matter. Now, to get to that, Intel is pretty heavily invested in finding ways to make these ideas happen. And our latest microprocessors, which sit at the heart of these new fine products, is the Intel Xeon E5 2600 and a couple of other families of microprocessor. But there are a number of technologies built into the Xeon family that are specifically intended to make these ideas happen. And you start thinking about some of the problems that people have. Well, the first thing that you've heard about in some of the themes is, I need to compute faster. Why? Well, I may want my answer to be done more quickly. Or if I want my answer to be done more quickly, I want to be able to have I want more time to do more studies. People are still dumbing problems down to be able to fit inside a workstation. You're finding ways to render smaller databases to be able to have things go quickly. More capacity means more accurate models. It means more simulations. And it means that you actually did get that re-entry model absolutely right. If you heard about the ride on Spaceship One, it made it. But boy, there were some moments when people had questions. And we do that by building in more computational performance. We've doubled the floating point performance generationally from our 5000 series to the E5 in one generation. Secondly, we've increased through the amount of memory capacity that can be brought to bear, and that's why you see these workstations that have the ability to put in much larger amounts of memory, larger model sizes, greater degrees of freedom in your analysis, more that you can do at a given moment. In fact, it's an interesting point, but about 10 years ago, I was talking to a customer in the workstation business in automotive, and they said a fundamental problem they had is they wanted to be able to get departmental rendering and departmental analysis deployed. They needed to build supercomputers and put them into each department. One Dell Precision T7500 has roughly the same computational power. There are some asterisks in terms of conditions around that, but the same compute capability as the number 166 supercomputer in the world only 6 years ago. You have a supercomputer underneath your desk when you buy one of these platforms. So the question is, what ideas are you going to unlock while you go do that? Now, the processor itself is wonderful and it's fast, and there's a lot more, you get a lot more degrees of freedom because of the large memory. But you do want to be able to connect to some fast I/O devices. We heard about really interesting usage models earlier from a number of people. You have connected computers. You have computers that are working through large network systems, large file loads. But we've integrated the I/O, the PCI Express bus, inside the Xeon E5 processor, which results in two things. One, you double the bandwidth, that's great, but you also lower the latency. So what do you get? You get faster access to your peripheral devices. All of this is goodness because it allows you more time, more creativity in getting to your ideas. And we heard a little bit about power and noise. Well, when you're having a great idea, the last thing you need to hear is a fan. And so one of the things that we spend a great deal of time working on is power management, intelligent power management, distribution, and technologies like Turbo, which look on the die and distribute power on the die to the areas that need it most so it runs faster. You really don't know about it. So there's a lot of art built into the microprocessor to help people bring out their ideas. Now, I won't bore you with this chart because I think we're going to hold me to about 7 minutes, and if I walk through it, I'd take the whole time. But just suffice it to say, it's faster. And you're used to that from Intel. It's a new processor, things go faster. But I want to tell you that there's more. We got a lecture from one of our larger customers that happened to be a studio customer about a year ago. who said that they completely reworked everything in their process by optimizing from single-threaded applications to really using multi-core, using the advantages of what we had at the time, which were vector instructions, known as SSE, built into our processor, now AVX, which are twice as wide. He was able to do his movies twice as fast. He was able to get better cuts, better effects. They were able to think and come up with entirely new ideas. And then he said, the reason I don't have custom pharmaceuticals I believe that can treat cancers is because you people haven't done enough yet to take advantage of the microprocessors that you have. So while it gets faster, there's more we can do. So, well, before we add additional power even get to these really cool technologies that are coming out in graphics, we have a much more capable heart built inside the system that you can use much more of today. And Intel's committed to that. We're working hard with developers like Autodesk to bring the full capabilities out of these microprocessors today. This particular example is really telling. It's a financial derivatives model that was being used as a proxy on Wall Street for performance. And it took about 12 minutes to run. By adding 18 lines of code, we were able to drop that on the processor without adding power, without adding extra devices, to run in 15 seconds. There's tremendous capability today in these processors that we want people to be able to get the advantage of. And those are built into these new systems. So as you walk through the different design points that we heard about, small, quiet, larger, from an entry-level workstation all the way to the most powerful workstation with largest memory and most compute capability, and the ability to expand to the most creative group of I/O devices. Intel builds throughout their good, better, and best. Relatively simple idea, but good processing, good bandwidth, better processing, better memory capacity and bandwidth, and then for the expert, for the people who really want to pull the most out of their ideas, who want to take up the challenge of finding ways to invent the next great movie, to invent the next great pharmaceutical. You have the 7600 and the 5600 models based on the heart, Intel Xeon E5 processor. With that, I just wanted to say thank you very much for the opportunity to come out here. Workstations are perhaps the most exciting segment of the computing industry because it allows individual creativity and expression, whether it runs from music to filmmaking, Wall Street trading, life sciences, whether you're an academic or whether you're a professional, and whether you're building wonderful movies like Hugo, this is the tool for you. And at the center of it, Intel will continue to invest in the technologies that hopefully will bring out the next generation of ideas. So thanks very much.